All right, everyone. Today we're gonna go back with a very interesting question. It's in a specimen paper for IB chemistry HL. This is an HL level, but this question can also be placed in an SL, which is a standard level. So it's a stoichiometry problem regarding the gas law. Most of the time, we know the gas law is the PV equals nRT, right? Most of us know that. And this is quite an interesting question, because most of the time, for most of the gas laws question, I think 99% of the time the number of molecules are fixed, meaning the amount is fixed. Only the P, V, and T is changing. So, like in the gas law equation, there are several variables, right? We have P, V, N, and T, right? R, of course, is a constant, so we don't touch it, right? In here, I want to distinguish the P, V, and T. These are the states of the gas, right? And N is the amount of the gas. So no doubt that all the P, V, and T, they are all variables, but the nature of these variable is different, right? N is the amount of the gas. Most For 99% of the question, the amount of gas do not change, right? And people often tell the examiner always, most of the time, give you problems that play around with the P, V, and T. But except for this problem, so I'm going to go over with you guys how we can attack or tackle this problem with the right approach to solve it. So here's a gas storage tank of a fixed volume, right? Say here, fixed volume contains, in the end, it must be something that's fixed, right? Fixed volume contains N molecules of an ideal gas at 300 Kelvin with a pressure of 40 kPa, right? N over 4 molecules are removed and the temperature is changed to 450 Kelvin. What is the new pressure of the gas in kPa, right? So usually here, what you want to do is, you see there's a lot of information, a lot of variables. I see most of the time students, when they approach, most of the common mistakes, you guys reach for the calculator, or we try to find an equation, or we try to plug in something, solve something, but we need to understand the nature of the problem first, right? So is to summarize the amount of information given to you in a mathematical format. What do I mean by that? What you guys need to do, okay? So because it describes a process, right? So you have here I have two stage number 1 and stage number 2, or phase 1, phase 2, depend on what you want, right? Let me follow me. Okay. So initially, what you have is a fixed volume, right? So you have V and V, right? Because the volume is fixed, they don't change. Stage number 1, you have N molecules, right? Correct? Huh? Stage number 2, you have, now this is tricky, right? They say N over 4 molecules are removed. So this amount is removed. You have, let's say N1 is equal to N molecules. Then we remove N over 4 molecules. So you guys may want to pause the video here a little bit and guess how many molecules do we have for stage number 2, otherwise N2. Okay, pause. Okay, so it's 3 over 4 N, right? You start with N, we remove N over 4, then you end up with 3N over 4, right? All right. T1 temperature is equal to 300 Kelvin, right? Pressure P1 is equal to 40 kPa. Here, you can change, or you can convert, or you don't need to convert. It's up to you. Most of the time, people will tell you to convert, but I say it's up to you, and you see in the later stage why that is the case. All right. So one more thing, we have T2, right? T2 is equal to 450 450 Kelvin. And we are being asked the new pressure. Pressure P2 equals question mark. All right. So these are all the information we have. Okay. So first of all, we are given the amount of molecules, right? Right. So in our equation, PV equals nRT. You see, we have V, we have P, we have T, right? So in this equation, I will show you a tactic to solve every kind of gas law question or gas law related questions. Okay, so what you want to do is you want to group all of the constant terms on one side. What do I mean by that? PV equals nRT, right? In our case, R is a constant, correct? Of course, it's a gas constant. That is why it's called constant, right? And this question is very special. We have V is a constant, all right? So what you want to do is move all of the constant onto one side and all of the non-constant onto the other side. Okay, so here I have, you divide R on both sides. I have PV divided by R is equal to NT, right? P is not a constant, so ideally we want P to be on the right-hand side, right? So we're going to divide. So we're going to have V over R is equal to NT over P. So now, on the left-hand side, this is a constant. Constant divided by constant overall is a constant, right? That means that the result of NT over P must be a constant, right? That will give us T1 over P1 equals to N2 T2 over P2. All right. So, like most of you know this equation, P1 V1 over T1 is equal to P2 V2 over T2. I think more than half of you guys don't know where this is derived from, right? So maybe try to derive this. Okay. The answer to this, you can easily find it on Google, right? Or watch my next video. Okay. All right. So now we have N1, N2, T1, TP2. Only one thing we don't have is this is the moles, right? This is the number of molecules, correct? But we do know that the mole is equal to the number of molecules divided by the Avogadro number, right? So these guys are directly proportional, moles and number of molecules, right? So, the ratio of moles is nothing but the ratio of molecules. So I can do N1 is equal to molecules, right? The number of molecules, big N1 divided by NA, T1 over P1 is equal to N2 over NA, T2 over P2. Okay, it may look a little bit scary to you, but what we can do is cancel the NA on both sides, right? Can cancel. So overall, we have N1 T1 over P1 is equal to N2 P2 over P2, right? So now it's just substitution. Our N1 is equal to big N. T1, I believe it is 300 Kelvin, right? So we have 300 Kelvin divided by P1 is 40 kPa is equal to N2, which is 3 over 4N. T2 is equal to 450 Kelvin. And P2 is what we are finding. So here I'm going to tell you why we don't need to convert kPa, right? Because first of all, you can see if you're given pressure in kPa, right? Result that you will find will be in kPa, right? And of course, you see the question asks you that the new pressure is in kPa, right? Kilopascal. So we don't need to convert. Okay, and of course, here's some dimensional analysis. I would tend to do a separate video on dimensional analysis, basically unit conversion and how you do with units. right? These are all the fundamental rules when you do anything related to math, right? So n and n can cancel, right? Kelvin can cancel. So the unit of this P2 must be kilopascal, right? So we will do some simplification. Okay. So here I don't have a calculator, but this question, the new paper one for IB chemistry, you guys are allowed to use calculator. So at this stage, you can solve this easily by plugging into a calculator, right? So you can simply, use a calculator to solve at this stage. All right. So what I'm going to have is I will try to solve for you guys without calculator, right? So I can rewrite the 3 over 4 like this. 40 and 4 can cancel. This become 10, right? 3 and this one can cancel. This become 100. 100 divided by 10 is 10 is equal to 450 over P2. So here P2 is of course 450 divided by 10. You will get 45 kPa. And that is how you answer or attack any stoichiometry question that involves gas law. So for more content like this, please follow the channel, and I will try to do more questions like this, more educational content, free content for you to keep up with your IB content. Thank you guys.